Is this something that you're having a problem with too? Why is this battery not charging? If you want to see the answer, keep watching to the end of the video and I explain what's wrong with it and how to fix it. Here we have two identical Milwaukee batteries. We're going to identify which is the good battery and which is the bad battery by checking the individual voltage in each cell of the batteries. When we identify the bad battery, what we will do is use this buck step down volt controller and bring up the voltage of the individual cells. So if you haven't already watched it, in video 1 we replaced two of these dead cells in this battery. Because when I put one of these batteries onto charge, I get the Christmas tree flashing lights of death, which means that this battery then is not charging. Here we have the Milwaukee battery, but how do we test the voltage inside the battery because we can't get our probes in there? So what we do is get one of these little spade connectors, shove it in there, we get a second one and shove it into the far one, and now we can get our probe into this. So just lining it up, looking over here, we have 12.3 volts and that's in a fully charged battery. So inside this battery is divided into three groups. So you have three groups of cells. So how do you measure each cell group? So what we do is take our negative one here. So this side is our positive. Put on the first probe. We have 4.12 volts. So now we get ready to check the next two, which is with the first one and the middle one. There's 4.1 volts. And now we check the third lot of cells, which is the last one and the middle one again. And it's 4.08, so basically 4.1. So it's close enough being 4.1. So now looking at this battery, from taking those three readings and the overall voltage, we know this battery is full and balanced. Here we have a second battery. It flashes the Christmas tree lights, so green, red, when we put on charge. So we're going to check this battery. So now that we have the two prongs into the center of the battery, the total voltage is 11.8 volts. So now we measure the first group of cells, which is 3.9. So checking the second group of cells is 3.58 volts. And checking the third lot of cells, if we can do it, is 4.2. So this battery is unbalanced, and that's why it won't charge. So what are we going to do about it? This is our Milwaukee battery stripped down. It's a 12 volt battery, but we know it's divided into three groups of cells. We've taken a meter reading of each of the cells, or the groups of cells, so there's three different readings. We've identified the lowest cells, so these ones here we're measuring 3.5. So how are we going to charge them that they're each charged at the same value? Because if you put it into the controller or the charger to charge it up, it won't charge because all the cells are different voltages. To make each of the cells level or the same voltage is to get one of these little guys. This is a buck step down boost controller. So the input voltage coming from my power supply is 12 volt. We turn it on with one of the leads disconnected. Our output voltage is 4.1 volts. So the maximum voltage that these batteries can be charged to is 4.2. So I've left it at 4.1 just in case there's discrepancy, in case this meter here isn't that accurate. So let's turn that off again. Reattach our lead. Now with our lead attached, the back voltage is coming in at 3.5. So it is back feeding through the wires at 3.5. So now what we can do is turn it on. And this piece here is how many amps is currently going into the battery. So it'll stop charging when it hits 4.1 volts and the amps will drop down to 0. Now after turning it on, we know that those two cells there that were very flat are now going to draw 1.3 amps to get to 4.12 volts. The way we can control how many amps is by turning this one here. We have a little screwdriver, and as we turn it, this is basically a choke or a limiter, so we can limit how many amps will go into these cells. I don't know how fast they can accept voltage, so I've limited it to 1.3. I think that's an acceptable number for amps to go in. You can bring it up to 2 amps, but I don't want to blow up these cells, so I think 1.2. as a trickle charge is probably okay. Okay, I'm just back. So it's been charging away and it's now at 0.6 of an amp. So we're just going to flick it off. So that's the backfeed voltage from the battery, and it's 3.9. So that cell there that was 3.5 is now 3.9 volts, and the maximum it can be is 4.2 volts. So we'll keep going until it reads 4.2 volts. Okay, let's test the cells. So this is cell 1, this is cell 2, this is cell group 3. So just after pushing the battery back in, and success! It's now charging. Booyah! Okay, now just to reassemble it and then we're done. Okay, now it's charging! Woohoo! So I fixed it. So I think long term the battery is probably coming to the end of its life. It is probably kaput. But just for a short term and just being a complete fun project, I wouldn't actually advise people to do this. I think it's just a bit of a fun project just to see, is it possible and how would you do it. This is how I did it. So if you like this type of video and this type of content, give it a thumbs up, subscribe over there, and as always guys, thanks for watching. See you later. Okay, just want to clarify this. These are not just your average lithium-ion batteries from a laptop. These are actually batteries that were designed for a high current discharge, for like drills, angle grinders, anything that's lithium-ion battery related. So these are power tool batteries. These are not out of your just run-of-the-mill laptop batteries. They were sourced that they have a high discharge capacity in them. So yeah, how do you know which ones to buy? Just Google it, look up reviews online, everything. Sony are quite a good brand, or Panasonic, but that's what I did. That's how I got these.